Okay, it got cut off, so this is part 2. Number 11, we had a 90% confidence interval. And we have, that means that the alpha is 0.1 and the t alpha over 2 can be found with the chart. I'm going to use the chart in this book, which is similar to the one online. And before I can find the t value, though, there's something that I need, isn't it? I need the degrees of freedom, which is n minus 1. And that, in this case, since we have 15 randomly selected, the degrees of freedom is 14. All right, so now we can look it up. 14 degrees of freedom, and I have an alpha of 0.1 on a two-tailed test. 14 degrees, 1.761. 1.761. All right. You want to see that one more time? Okay, so 90%, there you go. And so we want a two-tailed 90%. That's this column. We're going to go down to degrees of freedom 14. That's 1.7613. So in our case, I just rounded it to 1.761. If I want 1.3, I can use that. Okie dokie. All right, so we got a GPA of 2.86. So that's the sample mean. Average is your clue word there. So average usually means mean. 2.86. And it comes with a standard deviation S of 0.78. So now we have all the things we need to create a confidence interval. So our confidence interval, remember, is x bar plus or minus the t score times s over the square root of n. Now n is actually 15. Don't forget, degrees of freedom was one less, so don't get confused there. We got 2.86 goes in for that, plus or minus 1.7613. times 0.78 divided by the square root of 15. Right. So bust out the calculator and we figure out what that is. Right, let's see, parentheses, no. 0.78 divided by parentheses, square root of 15, close parentheses, okay? That's 0.201. And then I'm going to take that and multiply by 1.7613. And that will be equal to 0.3547. But it's 2 decimal places in the original mean. GPA are typically 2 decimal places, so I can round it down to 0.35 if I want. But again, they want the 2 values, the low value and the high value. So we're going to say 2.86 minus 0.35 and 2.86 plus 0.35, right? So that's 3.21, and that's, oh, I'm sorry, subtracting, you get 2.51, and adding, you get 3.21. There you go. And number 12. Okay, we got 90% confidence interval again. All right. That means my alpha is 0.1. That means my t is 0.05. And the same t-value, oh no, the t-value changes based on degrees of freedom. So let's figure out how many degrees of freedom I'm dealing with. Oh, no, that's not the question here. I started going without even looking at the question. The question says, how large a sample must she select? So I have that formula on your formula sheet. Sample size, when it's dealing with this, is n equal to parentheses the z-score times s over e squared. Isn't that interesting? Okay, so no t-score in this. Instead, we want to find the sample size. And the reason why we're trying to find a big enough sample size so that we can use the standard normal distribution. We don't have to use student t-score in that. We can just use the z-score. That's why there's a z there. Okay, so we got to find the z. The z of alpha over 2, so 0.05. And if you go to the z-score for 0.05, here, come with me. Look for 0.05. We've done this once before, but there you go. It's right there. It's somewhere in between 1.64 and 1.65. So I say 1.645. Okay. All right. Now we need S, which they gave us in the problem. They said that the standard deviation is 6 ounces based on earlier studies. And we need a margin of error, and it says within 3 ounces. Within 3 ounces. So the standard of error is within 3 ounces. Okay. So let's try something. 1.645 times the standard deviation, which is 6, divided by this error, which is within 3 ounces. We're going to square that. See if this works out. So parentheses 1.645 times 6, and then divided by 3, close parentheses, squared. And that gives me 10.8, which is going to round up to 11. And that is the correct answer. All right, thanks for joining.